So we are going to have the midterm this Saturday, and it will start at 10 o'clock instead of 11. I made a post to the forum. So hopefully everybody will see that announcement and nobody will be late to the exam. So right now we should start the block diagrams. So that's the next topic in we should cover. But I don't want to start block diagrams today before the exam, since there's really not many people in the class, and this will not be included in the exam. So I will just leave it after the exam. So before that, we were talking about the transfer functions, and we looked at how we can calculate the inverse Laplace transform of rational functions using partial fraction expansion. And then yesterday I talked about multi-input, multi-output systems. So if you have many inputs and many outputs defined for a system, then you can define a transfer function between each input and each output. So that means if you have like 5 inputs and 5 outputs, that will make 25 different transfer functions. And all these transfer functions can be written in the form of a matrix. So we call that the transfer function matrix, and the idea is the same, but it's just it now becomes a matrix. Okay. So since I don't want to start talking about block diagrams, if you have any questions, then we can talk about them. Did you look at the past midterm exams? So yeah, I know this. We still have like 3-4 days before the exam. So there will most probably be a question on a multi-input, multi-output system. So I don't know if you will need to do matrix inversion or not, but take a look at this example at least. And if let's take a look at some of the old exam questions, and maybe we can find something to talk about. Okay, so the fourth question you see here can be a good example to a multi-input, multi-output system. If you read this question, we are given 2 equations. Okay, so there are 2 outputs defined, x and y, and there are 2 inputs, e and f. Okay, so this is a system with 2 inputs and 2 outputs. So these differential equations are given, and we're in this question it is asked to draw a block diagram for this system. Since we haven't talked about block diagrams yet, we cannot do that at the moment. But still, we can take this question and play with that to see. For example, we can obtain the transfer functions for this system, and maybe it's a good idea to do that. Okay, so the original question asks to block diagram for this system. Block diagrams are not included. Exam. So let's use these equations. Transfer functions. There are 2 inputs and 2 outputs. So there exists a 2 by 2, not 3 by 3, So let's start by taking the Laplace transformation of these equations. So this is important. When you are doing that, when you're after a transfer function, you should assume zero initial conditions. Otherwise, while taking the Laplace transformation, you should include the initial condition terms. For example, the Laplace transformation of that is s square of x minus something like that, right? But these terms are not used here since we assume that they're all equal to 0. So the transformation of this gives plus 2 times s times x and plus 2 times x minus y is equal to the capital F of s. The Laplace transformation of the other equation is s square of y plus 3 sy plus 2 so from here we can collect x and y terms together to write the following: s square plus 2s plus 2 times capital X minus 2 times capital Y is equal to capital F. Similarly, s square plus 3s plus 2 times capital Y minus 2 capital X is equal to E. Okay? So at this point, we have two options. We can either solve for x and y algebraically from the two equations above, and let me start with that option. So for example, from the first equation I can write that y is equal to, this is the first equation, this is the second equation, so from 1 I can write So, by the way, I'm just solving this right now. If I make a mistake, you can just stop and correct that. So this should be minus, for example, right? So you can take this y and insert into the second equation. So you know where this is going, right? Maybe I don't need to do the entire solution, but let me just take it one step further. 2 times x, and I have a minus 2x here, so let me just include it here, times x minus Or let me just show it to the other side of the equality. So this is going to be plus. Now this 2 cancels. This thing. Okay, so hopefully I didn't make any mistakes. But so what did we do here? So we actually wrote one of the outputs x in terms of the 2 inputs of the system, E and F. Okay. So this, assuming that I didn't make any errors while obtaining these, but this should be the transfer function from F to X, and this is, well, E should be left outside, should be the transfer function from E to X, okay? And once we so let me call this 3. X from above Okay, so to make things easier, so let me just call this G11 of S, and let me call this G12 of S. Times F. Now there's just one step left, and that is to combine the similar terms together. So I have an F here and another F here, so I can put them into a parenthesis. G11 times S squared plus 2S plus 2 over 2 minus 1 over 2 F plus E12 times E. Okay, so now these are the remaining 2 transfer functions in my transfer function matrix. So this is my G21, G22. Okay, so it's just simple algebraic manipulations, but well, you should be aware of what you're doing really. I mean, so the procedure here is really simple. You're just solving 2 unknowns from 2 equations. And these are algebraic equations, so the solution is really simple. But what you obtain in the end is you obtain the elements in your transfer function matrix. So these G terms, the individual transfer functions are the elements of your transfer function matrix. So your transfer function okay, so for example, if I ask you to calculate the output x if f is a unit step function, what you need to do is insert, and e is 0, for example. So let's say find x if f is equal to unit step, which is the Laplace transform of which is 1 over s, and e is 0, for example. Then this is how you're going to do it. You're going to say x is equal to g11 times f, but that is 1 over s, and g12 times e, but since e is equal to 0, that should be 0, and you find this, and then from here you find the actual x in time domain by simply taking the inverse Laplace transform of that x. Okay? Şuraya mı? Ya da onu değiştirelim madem ya. So let E be a sine wave. So that's a better option. So let me find the Laplace transform of sine wave though. So let me first write the time functions. F is equal to u of t, and e of t is equal to sine omega t. Then E is the Laplace transform of sine omega t. So we should be omega over s squared plus omega squared. So I think this is better. So this is going to be plus g12 times this thing. So as I said, you should always be aware of what you're doing. You know, just automatically do something just because it was how it was done in the previous examples. So for example, if this is an aircraft or a helicopter, so let's assume that this is an helicopter, and these can be your flight variables like the forward speed and vertical speed. Let's say these are your outputs, and these may be your control inputs like the longitudinal cyclic input and the collective inputs for a helicopter. So you may be trying to find the response of your helicopter if the pilot gives two inputs at once. So he moves the cyclic in one direction and then he changes the collective input. So you find the Laplace transformation of those inputs, and then if you have these transfer functions, you can put them here, and then the result will give you how the forward speed will be changing, for example. And if you want to calculate how the vertical speed changes, then you use the other transfer functions, and that's how you calculate it. Okay. So this part is an important part of my everyday life, like obtaining these transfer functions from the equations. Okay. So this is something I routinely do. So when I try to analyze a system, I somehow obtain the differential equation for the system, and then I drive these transfer functions to simulate that system. So that's something we do. Well, obviously, I don't do the second part. So I don't do this part because I use just MATLAB to simulate the system. So I never really obtain x of s in S domain and then take inverse Laplace transform to obtain an analytic solution to the system. So MATLAB is used for this part, but the previous part, the obtaining the transfer function part, is something we do. Any questions?
I looked at this question before, and and we could just do the Laplace transform once, and then we could look at the relation like e comes in, x comes out, y comes out, and then x double dot, and then x dot x, and then we do the roots to feedback. For that question, where we have to draw the block diagram.
Well, the block diagrams are not included in this exam, so you don't need to worry about that. I will start the block diagrams after the midterm next week.
Okay, but we would have to do the Laplace transform, get a time domain, and when we get the time domain, then you can draw the block. I mean, it would be easier to draw.
Well, I can't say it's easier. It's just as easy. You can use draw block diagrams right from the differential equation, or you take the Laplace transformation of the equation and then draw the block diagram.
I know that block diagrams when there's one input is relatively easier because we have the output and the input. We do we can find the transfer function. But when there are two inputs, it's a little bit more tricky, I think. And we should we only do that in the time domain and then find the block diagram, or can we do the like f over x, like fx over rf, the transfer function? Can we do that? Two inputs, two outputs.
Yeah, you can do that too. Well, the thing is, the block diagram representation is not unique. You can draw many different block diagrams, and so it may be easier to use the time domain equations for one particular block diagram. But if you want to draw it in a different way, that may be easier to go to that from the Laplace transformation. I don't know if that answers your question or not.
I understand, because I remember there was many different ways of drawing them. There was like simple ways, complex ways, particular ways for different problems. So it depends on the question, I guess.
Exactly. So, for example, one way to make this problem more complicated is to give initial conditions. Okay, so I can ask a question like this, and then I can ask you to simulate the system for under asserted inputs, and the system is started from initial conditions. Then, so obviously, in that case, while taking the Laplace transformations here, you need to put the initial conditions into the corresponding places. So obviously, once the initial conditions are involved, then you shouldn't really call that a transfer function, because for transfer functions, we assume the initial conditions are 0. But nevertheless, the same effort still can be used to obtain the solution. Okay, so here I told you that at this point we have two options. We can either solve for x and y algebraically, and let me now show you the other option. The other option is to obtain a matrix solution. The other option for solving the system is to write the two equations, 1 and 2, in matrix form and obtain a matrix solution. So you just get these two equations. X minus 2 times y, and here I have minus 2 times x, and so if you call this A of S, Then you can write x and y as the inverse of A times F and E. So now the transfer function matrix is simply the inverse of this matrix. Okay, let's just write that A of S inverse is equal to 1 over the determinant of A times okay, so we should just switch the place of these two, right? This goes there and this goes here. And then these two changes signs, right? So they both become positive. See? It's easy. The determinant of A right? So these should be the same transfer functions as the other G1, G2, these transfer functions I found here if there were no mistakes. Okay? Any questions? Okay, so I would like to say a few things about the exam. So if you look at the previous exam questions, you will see that sometimes there are some straightforward questions. It's obvious what to do. But sometimes there are questions that requires you to think a little bit. I think those are the questions we need to ask. So that's how I feel. So I don't think really we should show you something here and then ask you the same thing in the exam again. So that's not really engineering. So I think engineering requires some creativity, some thinking in different ways. So that's what I try to do, and that's why I ask such questions. Sometimes after the exam, some questions complain about that. So they say, so this question was different. We didn't see something like that in the class. So why did you ask that? The reason is that, if you are a good engineer, you should be able to use the knowledge that is available to you, and then by using that knowledge, you should be able to solve questions that nobody has solved before, right? So if otherwise, just looking to a textbook and then doing the same thing again is not engineering, really. You cannot really create new things that way. So, for example, NASA is sending unmanned vehicles to Mars, right? I mean, think about the engineers there. So they don't have books that say how to send spacecraft to Mars that they can refer to, right? So they need to create their own solutions. So they don't have anything in front of them to use. They need to create. They face new problems that nobody ever thought about before, and they try to solve those problems. So that's. I think that's the real engineering. That's the real fun part of engineering. So that's why I try to teach you everything, by the way. I try to emphasize every point that I think is important in the class, but still in the exam I look for questions that require you to look at the problem from a perspective that I didn't mention before, and I expect you to be able to catch that. Obviously, not all the questions should be like that, as I said before. So the questions, I try to make the questions balanced so that even a student who has studied very little should be able to get something in return of his work. But a student who has spent like hundreds of hours preparing for this exam should be able to demonstrate his knowledge. So the exam should be able to differentiate that person from the rest of the class. So if all the questions are straightforward, then it will be hard to do that. So linearity is a good thing. So that's what I try to achieve. So if you consider a graph, so let's say the horizontal axis is the knowledge of knowledge of the student, and then the vertical axis is the grade. Okay? So the knowledge goes from 0 to, let's say, 100%. Let's say this is a normalized curve. So a student who knows very little, like 10%, should be able to get a grade corresponding to that. A student who knows everything should get a very good grade, like the best possible grade corresponding to that. And this relation should be a straight line, right? It should be a linear relation. So if you know half of the content, then your grade should be half of the full grade. So an exam that maps the knowledge to grade through such a straight line is, I think, the ideal exam. So if the questions are too easy, then it will be something like this, right? Somebody who knows very little will be able to get pretty good grades if all the questions are straightforward. Or if all the questions are such that it requires creative thinking, then nobody will be able to do that except the best students. In that case, the distribution will be something like this. So you know pretty much everything, but yet you get a very poor grade. So that's a bad thing. So these are all nonlinear relations, as you see. This one, let me use colors. So this is the ideal one, and that's a straight line. So that's a linear relation. See, there's a reason I like linear systems. So I think it's fair. See, the bad thing is I know the grades, right? At the end of the year, I will have all your grades. But unfortunately, I will not have the true knowledge of each student. So I never really get to create this line. Any questions? Bir seferinde öyle olmuştu. Sınavdan sonra çocuk böyle hışımla geldi bana. Hocam bu soru neydi ya? Biz onu gördük mü sınıfta falan diye. Ben dedim görmedik zaten. Şeyde oydu yani sınavın amacı da. Yani anlatıyorum ki şey olmasın.